Hello everyone, welcome to our autonomous vehicle course, the practical session. I'm Mohsen here from Tallinn University of Technology, your lecturer, and today we will go through all the material that we actually plan to discuss and teach you during this course. So first of all, let's just check the overview of the content that we will teach to you in this actually practical sessions. First of all, we have 6 weeks talking about some basics, starting from the Linux operating, the main operating system that we are dealing with, Git versioning actually approach, and as well we have some session completely focused on the ROS version 2. So basically we have some zero to ROS courses in this session, and then the first main session that we are going to focus is the mapping, which is part of our autonomous navigation plan. And then we have as well the autonomous navigation itself, which we actually using the Turtlebot simulation environment for doing so. And then we jump to the actual vehicle autonomous navigation software, which is Autoware in this case. And after working and practicing with Autoware, we will deal with some AV validation basically approaches. We will choose one of the simplest approach for a scenario based validation, and then each of these sessions has a dedicated assignment, which you can see we have task 1 to 4 here, and each of those have basically their own point. So these are equal point that in the actually in total you need to get 100 out of them. So let's just check out some basic introduction and requirement for this course. So basically, what is ROS? It actually is an operating system which is completely designed for robotic operations. So what actually ROS brings up for us is the basically combination of different features like plumbing, which is a kind of a workflow that you can manage all your process and basically know how those process and programs connect to each other. It gives you some basic tool for simulation visualization, which is really perfect for different tasks, and as well it has different already pre-built different capabilities like control planning and perception, which is really good for our autonomous navigation use case. And as well it's an ecosystem. It means that you can basically use different package which is already defined and already developed with from different partner or from different people all over the world. And as well you can basically create a software distribution and document your basically development on that sense. So for us, it's not just a software, or it's not just a pure platform operating system. It's an ecosystem that you can communicate with other developers through the world. So the history of ROS started from 2007 from Stanford Laboratory, and then since 2013 it's managed by Open Source Robotic Distribution Foundation. And today many university, many actually maybe companies actually dedicate and put their effort and basically research on ROS, because it actually uses the benefit of different communities, not just for example some well-known companies. Of course you can find different people, individuals, and as well some research group focusing on ROS, and as well sharing their effort and sharing their achievements through the different cloud-based spaces, and other people can use as well, because since you have a well-known and you have a defined already structure, you can share your effort with different people. And so ROS philosophy is actually is originated from a peer-to-peer basically communication. It means that individual programs communicate over defined APIs. So ROS manage everything here, define can provide services, can provide different messages, nodes, and topics. So it is distributed. So it means that multiple computer can run on the same network and just use ROS for communicating and passing different messages and running different programs. It is really good that it's a multilingual basically operating system. So it means that everyone with different background can use ROS for their own usage. So it doesn't limit to any specific programming languages. And it's really lightweight. You can run it on different hardware, starting from a Raspberry Pi or maybe a really high-end computer. And as well, it's free and open source. So let's talk about the requirement that we actually need for this course. So basically, as far we talk about ROS, we are focusing on ROS 2 distribution, and mainly among all those distribution, some of them are long time support, which you can see here. Humble and Jazzy distribution is one of them. But since we are going to use different other software which already support Humble distribution, our main focus is on ROS 2 Humble. You can find the documentation of ROS 2 Humble on the link, and as well checking out different basically distribution on the other link. Basically the platform that we are using is Ubuntu 22. So if you actually already have Windows, you can check out the video tutorial here for knowing how to basically install Ubuntu as a dual boot. So it is really straightforward, so don't worry about that. You can just check out the instruction and basically install it. So you can dedicate 100 gigabyte of your hard drive for Ubuntu. It's completely enough for our all the experiment and all the practices. So I assume you will go through it and install Ubuntu. Definitely in this link you can find some basic Linux command, which is really good for beginners. It would be really nice to have some basic knowledge about how to use the terminal command in Linux, because it would be much more easier for you for later development of our task and of our target script. So basically, since we are going to write some program here, that would be really good to use one of the text editor. So these actually text editor, there are many thousand text editor. Maybe you can find it on Ubuntu on those platforms, but I suggest to use VS Code, which is really easy to use, which is really funny, and I actually basically it's really how can I say it's colorful. It actually supports different program language. You can use it for other tasks as well, and it is much more easier for I to just follow the basically a script and syntaxes and find those bugs inside the program. And definitely you can use as well for pushing all your code to the Git. So it's basically two-side benefit for the VS Code. And then definitely I suggest it. There is a basic short video for you. You can follow that short video to know it better, to know how to work with the environment. It is really straightforward, so don't worry about that. You will actually know it better as well inside the instruction. When you follow the code, then there is nothing to worry about at this stage. And one of the important thing for you as well here is to know how to use Git. And what is Git? Basically, Git is a platform that you can control your versions, and specifically when you work in basically multi program environment. So there are different programmers at the same time working on the same project, and you need to have collaboration on a specific part, and then you want to merge your code together. So there should be some version controls and as well some branch control feature of the platform. So these are all together come with the Git. So there are different platforms that you can use. One of the uh, who support Git. So you can work, basically I suggest you can work on the GitHub, which is free to use. So it's a really cool feature that you can use, and you can store your code there, and as well you can create different basically branches. So it is a must for a person who want to start programming to know the Git, and as well how to share your actually development and just publish it for others. Another basically important tool that we need to discuss in this course is Docker. Docker basically is the container software, container basically platform that create a container of what you actually need to run. So imagine it's kind of like a virtual machine toolbox. So it creates a virtual machine and run everything on that container. So imagine you are running a software which needs Ubuntu 18 or Ubuntu 20 or anything like that. Then you containerize that with all the requirements already installed on that container. So you don't need to worry about all the prerequisite of program. So you just run the container and run your software. That's all. It's really easy to use, and you need to know it, especially for your future career. So that was actually all about our requirement that we will go through this course, and let's talk about some mapping and autonomous navigation. So as you remember, that was our first and second chapter, main chapter of this course. So first we will go through the mapping and then navigation. So for this purpose we choose the Turtlebot specifically inside the simulation. Turtlebot is a mobile platform. You can find it easily already, all the packages and everything in Rust inside the Gazebo simulator. So first of all, we create a virtual environment for Turtlebot and then autonomously map the environment. Basically, for running autonomously inside an environment, you need to know the environment. So you need to create a map out of that environment to autonomously navigate to your specific target. But we will have a specific task here. First of all, we need to map the environment. Instead of manually move the robot and navigate it to collect the data from the environment, we will go through the environment autonomously by just using the sensor measurement out of the environment and collect the map out of that specific custom environment that you later will going to basically build it. And then after that step, we go through the navigation step, which using the previous map and autonomously navigate through the different targets that you will define for your software. So basically during this task you will learn how to create a package, how to create a program, basically we call it node, and then use that node to autonomously navigate your specific Turtlebot through the custom environment. After you learn how to use mapping and how to use the autonomous navigation basically feature of the Turtlebot, we will jump to a real platform which controls the autonomous vehicle. So this platform, which is one of the popular open source platform which bigger communities supported, is Autoware. This version is Autoware Universe. So Autoware Universe is the latest version of Autoware platform, which using different element and different using different feature or element of autonomy, starting from sensing, then it goes to the perception, detection and planning, and finally the actuation, which go through all the hardware element of the car, which navigates the car or vehicle inside the map. You can see on the right side there is a image of the visualize environment of the Autoware. So we will go deeply discuss this, but just in case to know you what you are going to face later, this is the practice that we have selected for this course, to know how to control a vehicle, how to create autonomous navigation inside the map with Autoware software by using the simulation, of course. And after we actually check out the validation, check out the basically Autoware, we will go through a validation based on a scenario approach here in the Autoware. So for that case, we will select a scenario simulation program which is already built on top of the Autoware. So your task here is create a specific scenario, interactive scenario, vehicle with other road user, and then see how our autonomous software behave in those simulation. This is a really fun and funny and cool task to know if you can find a corner case, if you find a critical edge case scenario that our vehicle crash with other road user, and that would be the main aim of this course series, which is actually the validation of our autonomous vehicle software. So let's actually be prepared for the material, and thank you for listening.